So, today's show, cholesterol and fats, huge topic. Of course, we're going to get Ray Peat's philosophy on this. We'll cover lots of things from why cholesterol is so important, why doctors are trying to lower it, why our body needs it, our physiology needs it, and what can happen and what it means if it's high or low, and what we can do to actually lower it. As well as why saturated fats, yes, the right types of saturated fats are so important in our diet. So enough of me. I want to get Dr. Ray Peat on the show. Maybe let him do an intro of himself this time because I feel like I never do enough honor. Just one more key piece before I click him in. I always say this. We do the show. He volunteers his time, and I know a lot of people are emailing him left and right. So please, 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 I don't care if you send him a check for $1, $10, $5, $50, $100, whatever you want to send him to say thanks. If you're emailing him, sending him a check. You know, I know people that send him checks every month. We send him checks all the time. I just think it's important because he's donating, 1 to 2 hours of his time plus emails every month. So don't want to say any more of that, but hopefully you can take that and run with it and say thank you to Dr. Ray Peat. So let me get him on. Ray, you there?
Yes, hi.
How's it going?
Okay.
So I wanted to know if you wanted to just kind of introduce yourself to a lot of the listeners. I always do an intro, and I just feel like it never does you the justice. So I don't know if you want to take a couple minutes just to kind of give a brief history of who you are and kind of where you come from.
Before I studied biology, I was mostly studying language and literature and painting, and I had been interested in biology for a very long time, but I had a bad impression of academic biology from my high school experience mostly, but then seeing that in the 1940s there was a very big change in the nature of American biology, and that was powered by industry and government promotion of the gene theory as opposed to the field theory in development and health and so on. So I waited a long time until 1968 to actually enter a graduate program in biology, and I had learned enough about universities and biology to manage to get through the program without having too many conflicts with the professors. Most of the professors were very committed to the genetic determinist idea of what an organism is, and I was interested in the field concept and the environmental influences on the organism, and nutrition is one of the most important environmental influences on the nature of the organism. So I see our nature as being a matter of potential being realized according to the conditions of the environment, rather than the expression of a predetermined genetic program.
So you're also a writer, guys. If you want to check out Ray's philosophy and what he does, definitely check out his website at raypeat.com, RAYPEAT. He has umpteen number of articles on his website that are free. And check them out, download them, buy his books. You can buy his books from his website as well. They're a wealth of information. I mean, I think I've read each book 6 times over easily. So definitely do that. Check them out. But that's a synopsis of who Ray is. And today we're going to talk about cholesterol and fats. And Ray's done a lot of work on this. He's written a lot on this. And I think it's a huge controversial topic out there. A lot of people don't understand it. A lot of people are afraid of cholesterol. The medical community is making people afraid of cholesterol. People don't understand saturated fats. So hopefully today we can clarify a lot of these things, or Dr. Peat can clarify a lot of these things, to educate yourself so you understand what you're actually saying, the meaning behind what you're saying. So we have a lot of questions here from listeners. I got a lot of questions kind of written up, but I guess we should start with, kind of some basic questions. I mean, kind of on the political side of it or the Western medicine side of it, right? Why do you think America is so afraid of cholesterol and saturated fats?
I think it's driven primarily by the food industry wanting to sell their products. The seed oils, the seed oils were already seen to be toxic, cause sterility, degeneration of the brain and the gonads and so on. Probably from 1925, but especially in the 1930s and 40s, the very oxidizable seed oils were known to be toxic, and that was one of the factors in researching vitamin E as something to counteract the toxicity of the seed oils, unsaturated fats, as well as the toxicity of estrogen, which happens to synergize with unsaturated fats. And the pig industry had been looking for ways to make their animals gain weight and eat less food. And the George Burr, who's identified as the inventor of the essential fatty acid concept, himself discovered that the essential fatty acids slow the metabolic rate tremendously. The deficient animals eating sugar instead of unsaturated fats had about a 50% higher metabolic rate, but various people noticed that effect. And they found that feeding soy and corn to the pigs, because of the unsaturated fats suppressing their metabolic rate, increased the profit. Less food in, more pig out. And at the same time, they noticed that it was lowering cholesterol, just as one of its biological effects, a toxic effect, basically. And the paint chemists, the oil chemists, discovered that instead of using the expensive seed oils that were now being sold largely as pig food, the chemists discovered how to make paints and plastics from petroleum around 1950, and that decreased one of the big markets for soybeans in particular. Henry Ford had imported soybeans to use in the car industry. He made a car body entirely out of soybean plastic and hoped to replace iron with that. There's a picture of him using a sledgehammer to pound on one of his cars, showing that they were very strong. But by the late 1930s, only doorknobs and steering wheels were still made of the soybean plastic. But when the petroleum chemists learned how to use petroleum, that freed up the soybean market for pigs, and their production was great enough. They wanted to find new markets to replace the paint and plastics market. And so they started promoting the health idea of their soy oil, cottonseed oil, safflower seed oil, and so on. And the only biological effect other than sterility and dementia that were established for the seed oils was that they lowered blood cholesterol. And for several decades, people had been noticing that cholesterol accumulated in the walls of blood vessels, atherosclerosis. And although the first person who discovered that in rabbits had dissolved the cholesterol in unsaturated vegetable oil, he realized that cholesterol by itself wasn't causing the disease, but there had been these experiments that gave a basis for the seed oil people to say cholesterol is found in the hardened arteries and in the blood, and their oil lowers the level in the blood. So they argued by guilt by association that if it's in the blood vessel and the blood, then you can lower it in the blood and prevent the disease. But the very people who had made those discoveries had realized that it wasn't so. And in fact, in the 1930s, people had found that thyroid was enough to prevent the atherosclerosis, and at the same time it lowered cholesterol. Over the last 10 or 15 years, a Swedish doctor named Uffe Ravenskov has gone through the literature and shown just beautifully that there is no connection between atherosclerosis, heart disease, and the triglycerides and cholesterol in the blood. They are associated, but it isn't causal. And the experiments that had been done in the 30s showed that hypothyroidism and the associated changes caused by the lack of thyroid and metabolism were what caused the atherosclerosis. And the cholesterol seems to be there as a defensive reaction to protect the injured blood vessels.
So, just for the listeners, because you did you brought up unsaturated fats. Can you just elaborate maybe the difference between the saturated and unsaturated fats for the listeners? Because a lot of people don't really know the difference between those.
Yeah, it refers to the chain of carbon atoms in the fatty acid. In one case, they have all of the hydrogen atoms attached to them that's possible. So they're saturated with hydrogen. And if some of the carbon atoms lack the hydrogen, they just have their electron bonds more exposed to the environment. And that the absence of the hydrogen makes them more flexible instead of being sort of like a bottle brush bristling with the hydrogen surrounding the chain of carbons. It's more like a necklace of beads, flexible, where the hydrogens are missing. The bonds can rotate more freely. You get 2 or 3 or 4 or 5 of those double bonds, and the chain is bent at each place there's a double bond, and at the single bonds the molecules rotate freely, so you can get very flexible shapes when you have the purely or highly unsaturated molecules. And that flexibility you can see when you put a bottle of oil in the refrigerator. Coconut oil is hard when it's just a little cool, just below room temperature or even at room temperature. But olive oil has to be much cooler before it starts solidifying. That's because it's relatively saturated, and canola and corn oil have to be extremely cold before they'll solidify. And that's biologically important. One of its meanings is that if the organism lives at 40 degrees Fahrenheit, for example, and it contained butterfat or olive oil, its fats would be solid and wouldn't be manageable. For example, if an animal contained 30% fat and it all hardened, its subcutaneous fat would become stiff, just the way a steak, when it's in the refrigerator, the fat is stiff. When it's in very warm conditions, it becomes soft and flexible. So in the tropics, even fish in the Amazon River, for example, have fat as saturated as butter fat. And if you grow soybeans or corn in a very warm climate, their fat is saturated according to the temperature. And chocolate and coconuts grow in a place where the temperature is probably averaging close to 90 degrees, and so they need to have very saturated fat to be just for the biochemical manipulation of the molecules to happen. And if you had unsaturated fats, like is necessary for the cold water polar fish, for them to be flexible, they have to have triply or quadruply unsaturated fats. But if you had those in a fish in the Amazon River, the fish would oxidize its fats in just a couple of days. Even with a medium unsaturated oil, such as soy oil or corn oil, if you put a rubber hose into a cork in the top of the bottle and put the other end of the hose in a cup of water and leave the bottle at room temperature, the water will rise up the tube as the oil is consuming oxygen. It's just a constant process, even at room temperature. And if you raise it to body temperature, 95 or 100 degrees, then the process is much faster, and you have sticky, rancid oil very quickly. So it's a biological adaptation. You can make a pig have subcutaneous unsaturated fat, depending on the temperature of the weather that it's exposed to. If you put a sweater on the pig, it'll get more saturated.
It's quite interesting. So, guys, what he just said the past couple minutes, write that down. That's some really good stuff to educate yourself on the differences and why saturated fat is so important, the right type for humans, and why unsaturated fats can be actually quite detrimental. Now, you were talking about atherosclerosis. It's not the easiest word to say. Most Western literature, medicine literature, doctors, they always talk about cholesterol and heart disease. And if you even read the side of like Lipitor and stuff, it even says this medication has not been approved to prevent heart disease, but they still promote it for that. What do you feel? I know your thoughts on intracellular calcium and fibrosis and all that. Can you elaborate on what your thoughts are around atherosclerosis and heart disease and stuff like that?
The polyunsaturated fats that we unavoidably get in our diet, they're constantly breaking down, producing free radicals, and tending to cause inflammation and tissue injury. And if anything is disturbing the metabolism of a cell, that's more likely to happen. For example, the normal healthy oxidation through the mitochondrion keeps the electrons tightly controlled while they're being transferred from, say, a glucose molecule to an oxygen molecule. But if you take away some of the oxygen, the electrons in the mitochondrion will have no place proper to go, and they will escape as free radical potentiators, and so the cell becomes more oxidized in the absence of sufficient oxygen. So any stress of a cell puts out these electrons that can attack the exposed electron bonds in unsaturated fats, but the saturated fats aren't open for stray electrons. So every time you're limited in your delivery of oxygen to a cell, you're putting the unsaturated fats in the way of these stray electrons. And those will then start chain reactions that at the extreme, they form lumps of material called age pigment or lipofuscin. And these, the free radical oxidized fat fragments attach to proteins, and they collect bits of iron and other breakdown products from the free radical attacks on whatever is around in the cell. And these lumps of age pigment, because of their iron and fat fragments, are able to catalyze the consumption of energy and deliver energy from the enzymes to oxygen. So they can create a false mitochondrial effect, consuming energy and wasting oxygen. And then that accelerates the process because the real mitochondrion is further deprived of oxygen by these age pigment lumps. But before that happens, that tends to be at the end of the life. You get degrees of that happening in which oxygen deprivation and stress cause lower degrees of damage and inefficiency. Signals go out changing the conditions of the organism. For example, sending signals that more energy is needed, activating hormones such as cortisol, estrogen, and growth hormone. And these three hormones are very closely connected to the rising triglycerides and the damage to the blood vessel wall. And they tend to interact. Cortisol increases estrogen, estrogen increases cortisol, and they both increase growth hormone. And all of these tend to break down triglycerides into free fatty acids, which are more reactive, tend to become oxidized more quickly, cause more cellular injury. So the circulating fats in the bloodstream are, in the first place, activated by stress and unsaturated fats, and then these three main hormones increase the damage they can do, even though they normally would be part of a defensive repair process in the presence of the unsaturated fats. They magnify the damage.
So, in regards to cholesterol, when an organism is stressed, you mentioned how cholesterol will actually elevate, and I think a lot of people don't understand that. Why is cholesterol so important for our physiology, and why does it go up when one is stressed?
The whole stress hormone system, the things that Hans Selye popularized and studied for many years, he was concentrating on the steroid system, and that's the most powerful stress-induced system. The pituitary senses something wrong in the organism, increases its ACTH, which drives the adrenal glands in particular to take up cholesterol and to synthesize cholesterol from raw materials and to direct the cholesterol into the mitochondrion to turn it into pregnenolone, progesterone, DHEA, and finally cortisol. And the cortisol is the thing which has a short-term defensive reaction against stress. By one of its main effects is to turn protein into sugar so that the sugar can be used for energy to increase adaptive ability to handle the stress. But if you keep your cortisone up too long, you'll destroy too much of your protein tissues. So the before the cortisol stage of stress, the continuously activated adrenal tissue will be first producing pregnenolone, progesterone, and DHEA, and it's only when those aren't enough to handle the stress that the progesterone will be further converted into the cortisol. So the production of the cholesterol is the first stage of handling stress reaction, and then the cholesterol has to be converted into pregnenolone to further the defensive reactions. But the increased production of cholesterol itself is a primitive defensive anti-stress system, and the later stages, pregnenolone, progesterone, and DHEA, back up that basic function of cholesterol, giving it more dimensions of protection. But starting probably around 1920, people were trying to purify cholesterol and see what its biological effects would be. They found that I think they used about 10 different toxins, everything from pus from an infection to snake venom, heavy metals, chlorinated solvents, everything that occurred to them. They would give a lethal dose of the poison to an animal, and if they gave it a good dose of cholesterol, it would survive an otherwise lethal dose. And that has been done repeatedly. There have been some more specific things. For example, the testes are stimulated to more efficiently produce sperms in the presence of cholesterol, and the cholesterol has a direct activating effect on producing more of the defensive steroids and helping the cell do what it should do, as well as interfering with the toxic effects of chemical stresses and physical stresses. For example, hyperthermia that will cause your red cells to break down. If you add enough cholesterol, the cells won't be hurt by an otherwise deadly temperature. So it's just an incredibly broad spectrum protective substance.
So for the listeners, cholesterol rising under stress is a response, and people should understand that it's your body's natural response to stress to help fight stress. Now, the issue is with most people, it goes up, keeps going up, and it's never coming down. So what are your thoughts on that? Is it a conversion issue? You know, what do you need to make that conversion from cholesterol to pregnenolone?
I guess it was about 40 years ago, someone was looking at the effects of varying the amount of cholesterol going into either an ovary or an adrenal gland, and they found that if the thyroid hormone and the vitamin A nutrition were adequate, the amount of progesterone coming out exactly corresponded to the amount of cholesterol going in. So a very big portion of the cholesterol is being turned into the also protective hormones, pregnenolone, progesterone, and DHEA. And that is a massive turnover of the cholesterol that's being produced, but it depends on thyroid and vitamin A very largely. So the higher your thyroid function, the more cholesterol you're consuming. And in the 1930s, someone noticed that when the thyroid gland had been removed, people's cholesterol immediately went up. So they would measure the cholesterol and give them a thyroid supplement, and immediately, as the metabolic rate increased, the cholesterol would decrease. The blood cholesterol was a mirror image of their thyroid function. But the thyroid also supports the ability to make the cholesterol in the first place. But the level that a healthy person maintains depends on everything else that's happening. So that if you have, say, a 500 milligram cholesterol blood level, that's considered very high, and you can bring it down in a week to 200 or 180 just by giving frequent small doses of a quick-acting thyroid. And that is protective because it's what's needed for them to produce progesterone and pregnenolone, so they don't have to rely on the pure effects of the cholesterol for their anti-stress activity. If you lack something needed to turn energy into cholesterol, for example, sugar is needed. If something is causing you to be overloaded with unsaturated fats, and too much starch and unsaturated fats probably are the main reason for not being able to produce enough cholesterol. The thyroid will also help you overcome some of the blocks to producing cholesterol, but a supplement of sugar sometimes is needed to bring up your production of cholesterol, so that you don't want your cholesterol to get below something like 160 as a very minimum. In some studies, after they were seeing that some diseases such as cancer were associated with very low cholesterol levels, and instead of being that the cholesterol was being consumed by the cancer, it turns out that low cholesterol makes you susceptible to developing cancer. When there was a Hungarian study about 45 years ago that found that when they chemically lowered the cholesterol, the mortality increased from all causes: accidents, homicides, suicide, and cancer. A huge increase in cancer mortality as they chemically lowered the blood cholesterol. And the hormones that aren't being produced from the cholesterol are probably the reason for those increases in mortality.
So when it comes to making that conversion, now I know a lot of people follow your philosophy, and one thing certain people say is when they start following your philosophy to lower their cholesterol, the cholesterol actually goes up. Now, is that because of utilizing the tropical fruits that they haven't been used to, and they're producing more T3, so they're utilizing more, and it'll eventually come back down, or are they missing something?
Yeah, and no one is really sure what the optimal level of cholesterol is.
Right.
For example, looking at old people in rest homes, they followed their cholesterol levels and saw that the ones that lived the longest had pretty high cholesterol. I think the 270 was the number that corresponded to the longest survival. And in the Framingham study, they saw that people over the age of 50 who didn't have at least a 200 cholesterol level were more likely to develop dementia. And in a big study of violence, they divided populations into those with at least 180 cholesterol and those below 180. And the violent offenders were clearly connected with the below 180 cholesterol levels.
So going back to the dementia, and I think you mentioned in one of your books, you talk about people with low cholesterol, whatever that number is, there's a higher incidence of depression. And you talk about cholesterol is a precursor to pregnenolone. Can you elaborate on pregnenolone's effects on our brain chemistry? I know you talk about ACTH on that. Can you elaborate on that for the listeners?
Yeah, the several signals can tell your brain that you're suffering stress. For example, low blood sugar is one of the basic things, and the various things that amount to stress act on the stability regulators of brain cells. The GABA is a sleep-inducing peptide or fragment of the glutamic acid amino acid. Glutamic acid excites the brain. If you take off the acid, it becomes gamma aminobutyric acid, which sedates the brain. And the stressed brain will activate enzymes to produce GABA and turn off the excitation. And there are specific peptide signals that act parallel with glutamic acid to excite the brain and to interfere with GABA, the stabilizer, and the Valium-type sedative or tranquilizer acts on the GABA stabilizing system of the brain. If something is preventing the glutamic acid from being turned into sufficient amounts of GABA, Valium will fill in and activate the GABA system, and activating the GABA system turns off the stress signals and stops the pituitary from producing ACTH to activate the adrenal cortex. And progesterone and pregnenolone and many other things act on the GABA receptor system. And pregnenolone happens to be one that is doesn't have many other hormone-like effects. It's basically a stabilizer at all levels of cells. In the brain, its effect is on the GABA system to imitate Valium, to tell your pituitary that the stress is under control and to stop producing so much cortisol. So in early experiments testing the toxicity of pregnenolone, someone gave a group of mice or rats 10 grams of powdered progesterone or pregnenolone made into a slurry injected into their stomachs, and they didn't have any appetite for a few hours because being so full of powdered pregnenolone. But the only hormonal effect that they saw was that some of the animals that had been stressed and had excessive cortisol or corticosteroid before the dose of pregnenolone, when they were getting the huge dose, they were normalized. So the animals were more normal after that big dose than they were before the dose. For a person, that would be like eating a pound of progesterone all at once. Or pregnenolone, rather.
Yeah. So pregnenolone alone, I mean, could nutrition philosophies do enough if you're making the conversion to raise pregnenolone to help with brain chemistry, skin tone, and overall stress reduction? Or do you recommend possibly using a powdered pregnenolone to actually help balance that and lower cholesterol?
Yeah, it depends on how far the system has deteriorated. Many years ago, some Russians found just with isolated mitochondria that giving them pregnenolone would structurally restore damaged mitochondria and allow them to begin producing more pregnenolone. And that's similar to what people saw with isolated progesterone on slices of adrenal gland. When they would give the adrenal slice pregnenolone or progesterone, it would increase its production of progesterone. So in both cases, there's a positive feedback rather than the typical negative feedback. You give it some and it makes more, which means that the organism is designed as if it wants as much as it can get.
Right.
And ordinarily you can make enough from converting sugar to cholesterol, and with thyroid and vitamin A converting cholesterol to the other hormones. But when you have been poisoned with not enough of the needed foods or too much of the unsaturated oils, heavy metals, causing free radical reactions and so on, then it helps to use all of the supports possible, thyroid supplements, pregnenolone supplements, possibly DHEA and progesterone, saturated fats, sugar, everything that works in the same direction.
Right. Makes sense. Now, I just got an email from a listener, just to rewind it a little bit. He wanted to know if you could elaborate a little bit on why growth hormone, when you were talking about it being inflammatory, why is it inflammatory? Is it just in itself inflammatory? Is it the excess of it actually being inflammatory to the system?
Most of the research is designed to praise its beneficial effects, but there are some very basic observations that people who have been chronically deficient in it have a remarkable absence of atherosclerosis. The mice that genetically are deficient in the pituitary hormones have no growth hormone. They aren't very big, but they live 2 or 3 times as long as normal mice. And one researcher removed the pituitaries from several species of animals and found that they lived much, much longer than animals with their pituitaries if they were given basically a thyroid supplement to keep their metabolism going. So when you have hypoglycemia, you increase your growth hormone, and it tends to come with the other pituitary stress-responsive hormones. And all of these tend to have their side effects. So they're all beneficial in the right amount at the right time, but they're all harmful when they go on too long or too high a level. People with the giantism, acromegaly, from for example, a tumor or overactivity of the pituitary gland, they have an extremely high incidence of atherosclerosis.
So we're talking cholesterol. Can you explain just you can get as deep as you want, I know, but the basics for people in the differences between HDL and LDL? Both of them are able to participate in detoxification. The protein that helps to carry the cholesterol in the bloodstream itself has some very specific anti-stress, even antiviral activity. So they're part of our ability to respond to stress, the protein as well as the cholesterol associated with the protein. And they're both defensive and both important, but the LDL is mostly the one that carries cholesterol into the places where it's needed, the brain, the ovaries, testicles, and adrenal glands. But anywhere you're making steroids, and that includes the skin. Skin is probably our biggest endocrine gland. The brain is the next, and then the ovaries, testicles, and adrenals. And the HDL has probably some more specific antitoxic effects, where the LDL is more a delivery system of cholesterol itself. And toxins will tend to increase the HDL relative to the LDL. Toxins of
most types will increase both of them defensively, but the chlorinated hydrocarbons, radiation, estrogen, and alcohol, for example, will increase the HDL relative to the LDL because it has some more specific antitoxic effects.
Now, I know you've talked about before how DHEA can actually lower LDL cholesterol. I think I read that in one of your articles. Can you elaborate on that a little bit?
Can lower which, the LDL?
Yeah, I think it was the LDL.
Well, anything that is activating the turnover, increasing your metabolism, progesterone redirects your metabolism. DHEA intensifies some of the cellular turnover processes. Thyroid is the basic thing increasing the turnover. And the turnover of cholesterol, besides making more of the pregnenolone, progesterone, it's also important to keep it turning over so that it doesn't sit around and get oxidized in the presence of the unsaturated fat breakdown products, which everyone has exposure to. So everything that increases your metabolic rate, such as thyroid, DHEA, coconut oil, and sugar and salt, all of these things can potentially lower your cholesterol just by increasing its use, but it depends on where you're starting. They can potentially increase it if synthesis is the limiting factor.
So it's really just going back from cholesterol, the conversion, having those things, sugars, T3, vitamin A, to pregnenolone to produce DHA and so forth.
Yeah.
Okay. Now, I know you've talked about light therapy a lot and how or just even light. Can you talk about how you mentioned how lack of light can actually cause an increase in cholesterol?
Someone took blood samples every 15 minutes during the night and recorded whether the person was awake or not. And as soon as the lights went off, the cortisol began rising. And it continued pretty steadily through the night. And sleeping decreased the rate of increase of cortisol. But it shows that the stress system recognizes very immediately, in less than 15 minutes, that darkness is stress in some way. And that seems to be that the intrinsic oxidation free radical production gets out of control in proportion to the exposure to darkness. When you measure the cytochrome oxidase, which is what delivers food electrons to oxygen, it's the last step in the mitochondrial energy production.
Right.
If you measure that during darkness, it degrades. And after several hours, like in the far north, where you have 15-hour nights, after about 12 to 15 hours, the mitochondria swell up. Some of them explode and leak their contents. Just from the 15 hours of darkness is fatal to a large proportion of the mitochondria. And first they produce more and more cortisol, but finally they're overstressed and simply die. So that's part of the aging process, is being exposed to the prolonged stress of darkness. And when they shined red light on the heads of experimental rats, the red light penetrates very easily, but it happens that the cytochrome oxidase enzyme contains copper in the blue state of copper oxidation, and the blue copper absorbs red light, and there isn't very much of it, so that the red light passes very freely through the tissue without being absorbed randomly, and so it's delivered to the copper in the oxidative enzyme, and it restores the copper to its proper functional role. And that's apparently what's lost during exposure to darkness. The use of the cytochrome oxidase enzyme in effect wears it out in the dark, and it needs to be recharged by light. And you can see similar effects if you expose a bit of tissue to sunlight. The blue light and ultraviolet light will excite electrons the same way X-rays excite electrons in hard tissue, especially. The excited electrons can last for years or decades in the hard tissue, such as the tooth or bone. But in the soft tissue, these excited electrons can be detected in an electron spin resonance machine for hours after being exposed to sunlight. So you can tell the history of a seed or a bit of tissue by measuring the state of its electrons, whether it was exposed to blue or ultraviolet light. But while you're measuring it in the machine and expecting it to be able to show excited electrons for hours, if you shine just a burst of red light at the tissue while it's in the machine, it quenches those excited electrons, and they go back to their resting state. That's apparently what's happening in the rat experiment, restoring the copper by absorbing red light puts the electrons back in the proper arrangement.
So you might have said this. I just want to kind of repeat and make sure I heard this correctly, that it's almost in a simplistic sense that light stimulates cellular respiration, progesterone, which is stimulatory to the thyroid, which helps with the conversion, where darkness is more stimulatory towards estrogen, serotonin, those things, which are antagonistic to the conversion.
Yeah.
Okay, cool. Guys, don't forget we're taking calls 347-426-3546. If you call in, hang tight. I'm not going to interrupt Ray when he's talking. So if you call in, just be ready to be on hold for a couple minutes, and I'll definitely chime you in. So don't forget to call 347-426-3546. Can you talk a little bit about circulating cholesterol in correlation with vitamin D and calcium absorption? Is there a correlation?
Oh well, no, not anything I can think of. A toxic level of vitamin D is one of the things that can injure the blood vessel wall, but at physiological levels, possibly interacting through parathyroid hormone would be an indirect way that they would relate.
Okay. Now, I have a question from, not a caller, someone emailed me the other day, and I'm going to read you the question. I'm pretty sure it's from a radio show that you were on. I don't have a date, but it says his statement, which I'm assuming it might be you, so you can correct me if I'm wrong. And it states that it is possible to live entirely without eating fats because your body can make all the saturated fat it needs. In the early part of the last century, animals that lived on fat-free diet were completely free of spontaneous cancers and lived longer than normal. So the question is, if the body can make all the saturated fat it needs, what's the importance, if any, of consuming saturated fats?
One thing is that makes the food a lot pleasanter to eat. It makes it digest more efficiently and steadily. Experiments with a loop of intestine, they would put just proteins or just carbohydrates or just fats in at a time, and they found that the digestion was very poor until you had all three types of food present at the same time, and then it was as if the intestine needed a complex stimulus before it would really effectively start absorbing and digesting the food. So it's partly a stimulus to your intestine to handle the protein and carbohydrate effectively. And it's a signal of satisfaction that helps to lower stress, to have fat and sugar in your food.
So I guess that we should ask, in a homeostatic state, which is, I guess, hard to get to for a lot of people, can a person, or should they, live on a quote-unquote fat-free diet because the body is going to be working efficiently? Or no? I mean, you highly recommend, especially in this day and age, people definitely increasing their saturated fat content.
Yeah, largely because of the effect on the taste system and the intestine reflexes. It helps to handle the other foods efficiently and to make the whole body recognize that it's being fed properly.
Right.
So it's part of the reflex nervous system that guides eating, and it helps to satisfy the appetite.
Right.
And so people feel more satisfied when they've had fats, especially saturated fats. And the experiments with the rats, they used a purified diet, and when saturated fats were added, they had similar cancer-free results. It's a very small amount of unsaturated fat that is responsible for the stress and cancer production.
Right.
The equivalent of just about a teaspoonful of unsaturated fat per day is enough to show a threshold increase in the incidence of cancer. And when we eat natural foods, we're always getting some of the unsaturated fats, and it's hard, even eating coconut oil and butter fat and beef fat and so on, they only have about 2% unsaturated fats, but on a normal diet, it's hard to get down to that
right.
threshold of about 4 grams of fat per day. And so that's, besides eating the most saturated type of fat, that's one of the arguments for using carbohydrates as a major part of your energy supply, because if we have some extra carbohydrates, more than we need to burn at the moment, they will turn into saturated fats and extend the proportion, so that in effect you can lower the unsaturated proportion below the threshold of carcinogenic fats.
Right, that makes sense. I get some questions on coconut oil and stuff. We got a caller. Do you mind taking a caller?
Okay.
Caller from the 450, you are on the air.
Yes, hi, Just. This is GP.
Hey, JP, what's up, buddy?
No much, you. Hi, Dr. Pete.
Hi.
This is Jean-Philippe Groux from Montreal.
Uh-huh.
Hi.
Hi.
I have a big question for you. You know what? I have a best friend of mine. Now, I don't know if you can answer me, but it's contract HEV now, and I recommend him some of your recommendation about saturated fat and aspirin, but his last blood test showed that the CD4 and CD8 drops down. Do you have something to help him?
What about niacinamide? People with HIV often have a very high polyunsaturated fats circulating, and niacinamide is something that will help lower the free fatty acids.
If you lower the free fatty acid, the CD4 and CD8 increase again, or?
I think so.
You think so? Okay, because you know what, his doctor advised him to begin the tritherapy, like AZT, I think. And I don't know if you're, you advise that or you have other recommendation.
I think
because I read a lot of it about coconut oil. I try to explain him that coconut oil are very, useful when you contract HIV, and I gave him maybe 5 tablespoons per day, but if the CD4 decrease it, I don't know what explain him to that,
Sugar, niacinamide, and aspirin are all things that help to lower the stress and keep the immune system up. Okay,
but when you said aspirin could be, 15 aspirin per day?
Around that.
Around that. Okay, that's very good. If I have some things going wrong with him, I'll let you an email. Thank you very much, Dr. Pete.
Okay.
Thanks.
Thanks, JP.
Bye, Just. Yes, bye.
Bye. Great stuff. Thanks, JP. Let's talk about coconut oil, because people out there, even our clients, everyone's just you say saturated fat, and it's just like, bam, people are so against it, and they don't know why. But we know when we talk about saturated fat, of course there's others, but, you're a huge proponent of coconut oil. Can you elaborate on why in regards to metabolism, hypothyroidism, the liver, just as much as you can put out there for people?
Any of the saturated fats have an anti-inflammatory protective effect. A group studying liver disease has found that the fish oils and shorter seed oil unsaturated forms increase liver inflammation and tendency to become fibrotic and cirrhosis, and that can be blocked by the saturated fats. I think it was an Indian that noticed that alcoholics in India who lived in the areas where they had ghee or butter as their main fat didn't develop liver cirrhosis despite being alcoholic. And they began testing that and saw that alcohol activates the unsaturated fats to react with iron to break down and produce the liver damage. And so all of the saturated fats are protective when you have an inflamed situation. And that goes all the way up to the waxes, such as extracted from beeswax and sugarcane and such, the super long chain saturated fats. And the coconut oil is in the medium chain length. It includes some of the very short chain saturated fats. Mostly it's 14 and 16 carbon chains. And the shortness of the chain means that it's very mobile in your system, and the shorter saturated fats can be handled in the mitochondria without relying on the transport systems for handling 18 chain carbons, for example. The 10 carbon chains can be oxidized as easily as glucose, and so instead of interfering with glucose metabolism and switching the whole mitochondrial function, they can participate and even activate the glucose oxidation, and they interfere with the anti-metabolic effects of the unsaturated fats. By interfering with the anti-metabolites, they let the mitochondria run at full speed, and that works as if you're giving a thyroid supplement. The unsaturated fats interfere with all of the effects of thyroid, all the way from the gland secreting the hormone and the proteins transporting thyroid hormone and the cells responding to it. So at all of those points, the coconut oil is probably getting in the way of the suppressive effects of the polyunsaturated fats, but especially in the mitochondrion, where the coconut oil itself is being very quickly burned and used as energy.
So the interesting thing for the listeners, I'm going to summarize that if I can, is that saturated fats help to protect the body and detox from unsaturated fats. They help with glucose oxidation and kind of reteaching the liver how to store glycogen and helping with blood sugar regulation. Saturated fats like coconut are pro-thyroid and anti-inflammatory.
Yeah.
Okay.
Yeah, and speeding the metabolic rate.
Yes.
That's the most important thing the thyroid does, and
right.
And sugar and coconut oil work right with it to maximize the good metabolic oxygen consumption.
And it's interesting because, at least with our clients, there's other things we've done, but to lower people's cholesterol, we've actually increased their saturated fat. And most people just get, completely, blindsided by that, but it definitely works. Can you talk about, you've quoted, I think it was Hussein in a lot of your articles about coconut oil and its effect on the pancreas. Am I correct? Can you talk about that a little bit?
Yeah, he was experimenting at the time he was working. He was just discovering the multiple factors that regulate blood sugar, and saw that the pituitary would activate the adrenals to increase cortisol and raise the blood sugar, while the pancreas was making insulin to lower the blood sugar, and the coconut oil and sugar worked very similarly to keep the system working, to allow insulin both to function and to be produced. And he didn't know at that time. There were a lot of things about the interactions of pituitary, sugar, adrenal, and so on that hadn't been discovered yet, but working just with those few elements, he was on the right track.
Good stuff on coconut oil. Let's talk about milk, and then I want to talk about eggs because we're talking about saturated fats. And we know, or the people that are listening, how much of a huge proponent you are of course, the right type of milk for that person, because of it's a complete macronutrient and saturated fat. Can you just give us, some of your thoughts on why it's so important, why should people be using it in their diet? Because most people out there, nutritionists, are actually not promoting it and saying it's actually quite inflammatory. And you actually promote it as something that's anti-inflammatory.
I think the calcium content, besides it contains such a broad spectrum of all of the nutrients, but the disproportion of calcium is, I think, what makes it anti-inflammatory. And that there are lots of ways that the calcium is working. One is that it increases the oxygen-using ability of the mitochondria the same way thyroid does. It specifically activates some enzymes, the uncoupling proteins in the mitochondria that turn on a higher metabolic rate. But systemically, it's suppressing the parathyroid hormone, and the parathyroid hormone is another of the short-range protective adaptive hormones that, when it continues too long, becomes counterproductive and contributes to degenerative diseases. The people on kidney dialysis tend to get very high parathyroid hormone, and because of an imbalance of phosphorus and calcium, and the parathyroid hormone is what eventually tends to kill them, causing all kinds of stress reactions, aging reactions to be intensified. And having a chronically high calcium intake gives you a chronically low parathyroid level. So the parathyroid isn't taking calcium out of your bones and tending to put it into your arteries and kidneys and so on. Keeping the parathyroid hormone down protects your arteries and kidneys and bones, and allows your insulin to do what it should to keep the free fatty acids under control, and the whole system tends to function in a smoother way when you keep these stress hormones minimal.
So the calcium downregulates parathyroid hormone, which downregulates inflammation. So you talk about how the dairy in itself is actually prothyroid, which can help with the conversion of cholesterol. Is that because of the progesterone in it?
That's just one minor factor. Human milk, at least, contains enough progesterone and thyroid to meet the baby's needs. So the babies that are born without a thyroid gland, if they're being breastfed, will not have any hypothyroid symptoms until they're weaned. So human milk has a full supportive endocrine system in it for the baby, and cow's milk isn't as appropriate for human use, but it still has some of the metabolism supporting hormones as well as the nutrients.
Mm-hmm. Guys, don't forget we're taking callers, 347-426-3546. You're welcome to call in. Ray's taking callers today, so definitely feel free to call in. Let's talk about eggs and fat. Can you elaborate on why you feel eggs are an important staple of people's diets? I know Dr. Brewer talked about that as well. Is it the fat content? Is it the protein? Is it the combination of both? Or is there something else in the egg?
With the industrialization of the egg industry 40 years ago or so, the cholesterol content of eggs went down quite a bit, and the polyunsaturated content went up. So if you can get non-industrial eggs from chickens that have pastures and and can eat varied food, the eggs are going to be a lot better. But the cholesterol in the egg seems to be one of its important nutritional values. Something like 600 milligrams of cholesterol in your diet from some of the experiments. It increases the oxidative stability of your lipid particles in your bloodstream, makes them less atherogenic.
We got a caller I'm going to take, if you don't mind. Just popped in. He's been waiting for a little bit, actually. Caller from the 949, you're on the air.
Hi, this is Danny Roddy. Hi, Josh. Hi, Dr. Pete.
Hi.
What up, Danny?
Hi, I just wanted to ask Dr. Pete, I know he's talked about this a lot in his articles, but basically a lot of people in the paleosphere are under the impression that free fatty acid in blood is a good thing. So I was curious if Dr. Pete could elaborate on that and perhaps explain how that can be harming to the liver and the thyroid.
What was the material in the blood?
Free fatty acids.
Free fatty acids?
Yeah.
Yeah.
Correct. Can you explain why somebody would not want that to happen, i.e. like a low-carb diet?
Would not want which to happen?
He's saying that there's a group of people that follow the paleo diet out there, which is a high-protein, low-carb diet. And they're saying through their research that having higher levels of free fatty acids in the blood is actually beneficial. And you're saying it's not. So he was asking you to kind of elaborate on it.
Yeah, that's my main argument against eating a high meat diet. That's one of the important functions of sugar, I think, because my next newsletter in 4 months, I think, will be talking about free fatty acids. But basically, they're one of the means by which stress causes its damage. I've known people who were eating 2 or 3 pounds of meat a day and who were getting sicker and sicker as their free fatty acids and free amino acids increased. And that started me reading more about the free state of fatty acids in the blood. And just about everything that goes wrong involves free fatty acid increase. If they're totally saturated fatty acids, such as from coconut oil and butter, those are less harmful, but they still tend to shift the mitochondrial cellular metabolism away from using glucose and fructose and turning on various stress-related things by lowering the carbon dioxide production, I think, is the main mechanism.
Amazing. Thank you so much, Dr. P, and thank